Okay, what we're going to do is we're going to do problem 3 here, and then we'll deal with problem 4 in a separate video. Okay, and then you have some more questions to try and tackle. So what we're going to do is try to identify all of this information from this completing the square process. Okay, some of it is readily available at the moment. It will become readily available as we work through this process. And it's a nice introduction into the last part of what we're going to try and work on today is solving for the roots. Okay, and then I will solidify that process in problem 4. Okay, so what we're going to do here is we're going to apply our completing the square process from lesson, or like the first part of this lesson, part 1. In that I'm going to identify the vertex via the completing square process. Okay, so what we're going to do is we're going to take this function f of x, it's a quadratic, and I'm going to write it, it's currently in standard form, I'm going to write it in vertex form so that I can identify the vertex. Okay, there is one thing that I could probably do right now, right off the bat, as a kind of a recap. Standard form is good for one thing, and very well, or the one thing that it does very well is it gives you the y-intercept. And so we know with the y-intercept, that's the y-intercept is the evaluation of the function when x is equal to 0. If x is equal to 0, anywhere with an x is going to disappear. Okay, and so what are we left with? We're left with that negative 7 over 2, which is 3.5, negative 3.5. Okay, so the y-intercept is going to be 0 and negative 7 by 2, which we know as being 0 and negative 3.5. So I can go right now without having even started this question, and I can go plot that point right there. That's a point on the graph. Okay, so the rest of it's going to require some of our completing the square process and one additional thing at the end for the x-intercepts, but we're going to see a little bit of an application of our completing the square now. Okay, so you are responsible for being able to produce these graphs. Okay, this is just a nice way to do it. Okay, I think the completing the square process is kind of one process that we can build off of in order to get all of the information. Whereas in the past we would have had something like we would have had factoring to solve for the roots and then finding the middle of the roots and substituting that in and finding the vertex. That's the other one we did in grade 10. This is just a little bit different. Okay, we're doing the exact same thing as grade 10 in trying to produce this graph. Okay, it's just in a different way. So without further ado, let's give this a go. Okay, so f of x is going to equal, I'm going to factor that negative 1/2 out. So it's negative 1/2, open up a square bracket, we get x squared. When I divide 3 by negative 1/2, I'm going to get minus 6x, close that square bracket, and then minus 7 by 2. Okay, so now f of x is going to equal negative 1/2, and then we're going to get x squared minus 6x. I need to find that plus c minus c value, if you recall from the last video, and we do that via the z value. It's b divided by 2 squared, which is negative 6 divided by 2 squared, negative 3 squared, 9. So I'm going to add 9, take away 9, minus 7 by 2. So f of x is going to equal negative 1/2 x minus 3 squared minus 9 minus 7 by 2. Distribute that half in, that negative 1/2. That goes to both things, don't forget about that. Sorry, that first one was a little big, it goes here or there. So we're going to get half of negative 9, or negative 1/2 times negative 9 is going to be plus 9 by 2 minus 7 by 2. Okay, 9 minus 7 over 2 is going to be plus 2 by 2, which is 1. Okay. Okay, so our vertex is going to be 3, 1. We can go plot that now. Okay, that's 1.31. The equation of the axis of symmetry, we know here, okay, this is the vertex. We know that the axis of symmetry, let me just make this a little bigger. The axis of symmetry goes through the x coordinate of the vertex, okay? And we label it as x equals whatever the number is. In this case, it's 3. It's because it's an equation, and it's specifically an equation of a vertical line. That's important. So that's x equals 3 as an equation. Ask for the equation, okay? The concavity is simply talking about, is it concave up or concave down? It's just a fancy way of saying it's a parabola opening up or down, okay? In this particular instance, it's going to be concave down. I got to change that back. Concave down, okay? When something is concave down, for instance, I know the parabola does something like this right now, right? Don't know exactly, but it's something like that. Okay, I'll draw it better in a second. But for sure, the thing we know right now is it definitely reaches a maximum, right? So there's a maximum. What is the maximum? There's a max of 1, a y value of 1, when x equals 3. Okay, now there's one other thing that we could do right now to produce this graph, okay, a little bit more accurately, and it is, if you're looking at this point, the y-intercept, this is actually a nice segue into lesson 2.5, which I'm not going to allude to yet, but we'll reference it tomorrow. That point with the blue circle around it, in reference to our axis of symmetry, we call it an axis of symmetry because it's like a mirror, right? And so if I have 1, 2, 3 units away from the axis of symmetry on that y value, then there's going to be 3 units away in the x direction at that same y value on the other side of the axis of symmetry, right? So I'm going to have 1, 2, 3. I'm going to have a point right here. So I know my quadratic, there's your 3 points right there, right, by the way. But our graph should look something like this, okay? I'm going to redraw it again in a sec with a little bit more accuracy, because I have one more thing left to answer with this particular question, and it is the x-intercepts, and it's kind of getting at what we're trying to do today as a whole, okay? So one more, or 2 more points, I suppose, to solve for, one more process to follow, okay? What we're going to do now is there is one single truth about every point along this green line on the x-axis. The one single truth is that the y values are all 0. Doesn't matter what point you pick. That point right there is whatever. It's got a y value of 0. It doesn't matter. Some number and 0. This point here, that's -1, 0. Over here, again, it's just some number and 0. They all have y values of 0, okay? So I'm going to use that fact to my advantage when finding the x-intercepts, because that's what that is, x-intercept. That's where the graph crosses the x-axis. So what I'm going to do is I'm going to take my function, I'm going to bring it down here, okay? And I'm going to solve for x, given that f of x is equal to 0. Okay, so what do we get? We get 0 is equal to -1/2 times x minus 3 squared, okay? And then plus 1, sorry. I'm just going to solve. I'm going to solve in the opposite order, the exact same way we've solved for stuff in the past in grade 9. We're going to solve for x, okay? We just have one extra little ugly thing in there in the squared, right? So we're going to get, I'm going to -1 from both sides. I'm going to get -1 is equal to -1/2 times x minus 3 squared. I'm going to multiply both sides by -2, right? So if I multiply this side by -2, I'm going to multiply this side by -2, and I'm going to get 2 is equal to x minus 3 squared. Okay, sorry, there's not much room there. Okay, now I'm going to do the opposite of squaring something. The opposite of squaring something is square rooting. The same way division is the opposite of multiplying, or subtraction is the opposite of addition. So I'm going to square root both sides. The only catch with that is when I square root both sides, I have to write the plus minus. Okay, and then I'm going to add 3 to both sides, and I'm almost done. So I get 3 plus or minus the square root of 2 is equal to x. Okay, from there, just like your quadratic equation, you're going to have 3 plus root 2 is equal to x, and 3 minus root 2 is equal to x. And so we're going to get one x value, the square root of 2. The square root of 2 is what, like 1.41 or something. So one of the x values is going to be 4.41, and one of them is going to be 1.54. That'd be like x1, and x2 is going to be 1.54. Somewhere in there. Okay. So I can plot those. They're x-intercepts. They have y values of 0, remember, from the very beginning of the question. So we're going to go plot that. 4.41, 1, 2, 3, 4.41 is somewhere in here. And 1.54 is somewhere in here, which fits our graph pretty closely. So there is your ability, or the process by which you can produce a quadratic on a graph using the completing the square process, which is what we're doing today. Okay. Problem 4 I'll do in a minute. In the next video, I'll do three videos for this lesson. It's a little bit big. But remember, we are looking for the x-intercepts. That's what we're trying to do. But we're using a process that in grade 10 we only really used for finding the vertex. Okay. So that's where we're at. Okay. I'll do problem 4 in the next video.